Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world.
So for today's podcast, I am here with Tim Hade, who is the co-founder and chief development officer of a fascinating company called Scale Microgrids. And we're going to talk about Scale and what they do and about microgrids. So Tim, great to have you on the show. Could you start by giving us a bit of an intro to yourself and your background, how you came to be doing what you do now?
Yeah, absolutely. Well, first off, thanks so much for having me, Ryan. So I guess, going back to the beginning, I started my professional career in the U.S. military. So I was on active duty in the U.S. military for 10 years. And as part of that experience, I learned a lot about climate change and the national security implications, at least from the U.S. standpoint, of what was happening with the climate crisis. And I think that was what kind of preempted me to want to go into this space after I got out of the military. Phase two of that was a few friends and I started working in the cogeneration space back in sort of 2009, 2010 timeframe. And at the time, right, I think we really saw it as an opportunity to do well and do good at the same time, right? We thought there was a good business opportunity, but it was also, reducing emissions, providing resiliency, helping our customers save money. And so we were really focused on C&I cogen. We ended up partnering with a UK-based company called Energy, and ultimately selling that business to Centrica, which I'm sure all your UK listeners will be familiar with. But, while we were building that business, I think really the inflection point for us was Superstorm Sandy, which was a massive storm that hit the New York, New Jersey area in 2012. And I think what that experience really taught us was that the United States electric infrastructure wasn't really built to handle the future threats that were going to, happen, right? And so it kind of gave us this belief that we needed to move faster and be a little bit more aggressive. And that's essentially the genesis story of Scale Microgrids. So what we've been doing for the last, 8-9 years is building distributed energy systems that are centered around solar storage, and also have a bunch of other components that we work with the end goal of being able to give our customers sustainable, reliable, low-cost electricity. And I think ultimately, we're one of a number of businesses in the distributed energy space, which is really driving kind of the bottom up, what I like to think of as a democratization of the energy system. And so, we play a small role in that, but I think the movement that we're part of is pretty fascinating in terms of the implications. And we've been working on that ever since. So it's been, as we can get into, a real roller coaster ride, lots of highs, lots of lows. Hasn't been the easiest thing in the world. But we keep chipping away. And I think, every day we're getting a little bit better at what we do. So that's kind of how we got here.
Cool. So just to help me, I guess, I'd help the listeners. And I'm going back to the origin story of you here. But when you say cogen, so in my mind, I think I know what you mean by that. But what do you mean by cogen? Heat and power, or?
Yeah, exactly. So yeah, cogeneration, which is also referred to more broadly as combined heat and power, is essentially the simultaneous production of electricity and heat. And so if you think about it at the highest level, most of the time when we burn fossil fuels, we do so at a relatively low efficiency. On average, like somewhere between 30 and 45% electrical efficiency, depending on where you are in the world, which means a lot of the potential energy gets wasted, right? It goes to atmosphere in the form of heat. And so the idea of cogeneration or combined heat and power is that if you can capture that heat and use it as a valuable resource, think heating water in a building, right? Or providing steam in an industrial application, then you can get the efficiency of burning whatever source fuel you're burning to be in the 80 to 90% range, which kind of benefits everyone. And so, that's a technology that we still, utilize in some of our projects today. But is at the end of the day traditionally reliant on sort of a fossil input fuel. So how big a role that's going to play in the future is, I think, the subject of a lot of speculation right now. But it's a very efficient way of using natural gas typically to produce heat and power. That's the high level way to think about it.
Yeah. There was a point in time a few years ago where people were working actively on launching like combined heat and power for domestic applications and small scale for industrial and stuff. But I think this kind of solar technology and battery technology really overtook it, particularly for the smaller systems in terms of how cost effective it is to deploy. So yeah, okay, cool. So then the microgrids part, that's a really, it's interesting that's you've gone straight to that space. So do you just want to unpack that a bit for us? Tell us what you're doing there.
Yeah. So I guess the easiest way to think about this is when you think about distributed energy resources as an asset class, right? And maybe if it's helpful for listeners, I'll just kind of break that down because I know I've said that a few times, right? So if you think about the way the electricity system has been built all over the globe for the past 120 years since electricity became a commercially viable product, it's always been a top-down system, right? So we've built really big power plants, and then we've connected the power that those plants make to loads via this very complicated network of transmission and distribution lines. And the reason we did that is because the way we used to make electricity, economies of scale mattered a lot, right? And we wanted to build the biggest power plant you possibly could and then connect it to load. That was the way we were going to get the best economic value proposition. Solar is really the technology that changed that because the economies of scale that apply to most generation technologies do not apply in the same way to solar. And so while it's still cheaper to build a 300 megawatt solar plant than it is to build a 3 megawatt solar plant, the economy of scale relationship is a lot different when it comes to solar. And so ultimately what we're going to see moving forward is there's going to be a lot of self-generation, right? So buildings are going to generate their own power with solar and batteries. And then you're going to sort of have a top-down system and a bottom-up system. And that's kind of what we're working on building as part of the energy transition. So that's generally the story of distributed energy. Now, when you talk about why it's good to build a distributed energy system, there's typically three things people focus on. The first is economics. That's sort of a whole debate unto itself in terms of why these systems are economic, but they are. The second is sustainability, right? Obviously, with solar and storage being the core technology of distributed energy systems, there's a big environmental benefit to building this type of stuff. And then the third is resilience. And resilience is really what got us into this game. And so if you think about the future of the electricity grid, the threat profile is pretty gnarly, right? So we built this electricity system thinking that the weather of the future was going to be like the weather of the past, right? We now know enough to know that that is not going to be the case. And so the first thing we have to do is we have to harden the electricity grid in the face of increasingly extreme weather events, which are happening basically all over the world, basically all the time.
Ironically, as a result of the way that we generate power.
Absolutely, right? And then the second piece of this is cyber, right? And so as we transition to a more digital electricity grid, the interconnected nature of the grid makes it a pretty hard target for cyber terror, right? And so if you think about the United States as an example, the entirety of the United States really has 3 interconnected grids. And if you take one of those grids down via a cyber attack, which is theoretically possible to do, right? the impact of that would be devastating on entire regions of the country. But this isn't specific to the United States. It's a threat that can happen sort of all over the place. And so that's essentially, from a resilience perspective, the argument for decentralization, right? Is that if you have buildings that can island from the grid and produce their own power, the value those buildings have to society in the event of an extreme weather event or a cyber attack, or really anything that sort of takes the grid down for a prolonged period of time, is inherently really, really valuable. And again, I think stemming from, our original sort of light bulb moment in Superstorm Sandy, which was what kind of changed the calculus for us, we really approached this from, we want to build the most resilient distributed energy systems that exist, and then do that in the most sustainable and economically viable way. And that's kind of how we've built our business. And that was kind of the natural on-ramp into the microgrid space, if that makes sense.
Yeah, definitely. There's a lot of complex things going on there. I mean, it's a complex system, but I'm sure people can understand. I mean, there are multiple movies where the energy grid or the big power station or something gets taken out and it causes a lot of trouble. And whilst they're movies, the sort of principles apply. And we've all seen the effects of more extreme weather and how that's having an impact on really critical services. So, why is a microgrid? What does a microgrid do to get you out of that hole? And why do we use that term?
Yeah. So, the distinguishing factor of a microgrid is it has the capability to island from the bigger grid, right? So there are kind of two kinds of microgrids that are built today. Some of them are what are called off-grid systems, right? Which means that you're building a building, you don't even connect it to the electric grid, you just make your own power, use your own power. That tends to be less than 5% of systems that are being built in the world today. Most of the systems are grid-connected microgrids, which means that you're essentially working in parallel with the electricity grid during most days of the year. And you're essentially playing economic games, right? When we're going to use power that's locally generated versus when we're going to import power from the grid is really based on sort of economic algorithms. So we're looking for the cheapest power. If we can produce the cheapest power, we use our power. If the grid can produce the cheapest power, we use the grid's power.
I have these problems every day. I have a solar system and a battery system, and I've become a bit of a nerd looking at the weather, and I'm trying to work out exactly how much power to put in my battery on the low cost tariff at night to then maximize the and it's I wish there was something out there that could automate that process for me and kind of do all of that, because I guess you don't really have to do it, but I kind of want to do it.
No, that's exactly right. And there are some good consumer companies that are coming online to sort of do that in the residential sector. But that's a big part of what differentiates us from competitors in the space, and kind of what differentiates microgrid companies, right? Is there's a big hardware component to this business, right? Which is obviously you have to figure out how to, procure big pieces of equipment, install them, commission them. So, the hardware piece is still a huge part of our business. But increasingly, right, the software piece, how you write those algorithms and who has the best, economic optimization algorithm is what's differentiating, different players in the distributed energy space. So that's a huge part of it, right? And so, that in and of itself is like a huge issue right now, right? Because a lot of that comes down to conversations with regulators and legislatures about how you actually structure tariffs to get sort of the, Pareto optimal for society. But yeah, that's a huge part of it, right? Is thinking about when should we use the grid's power, when should we use our power, and then batteries makes it even more complicated, right? Because now you have the ability to time shift, right? So we can make power, store it, use it later. How do we think about that, right? And so, the industry in general is really nascent, right? This is, really technology that's only been applied in this way for maybe 7 or 8 years, right? And there's a very steep learning curve. There's a lot of innovation going on in the space right now. But ultimately, I think, most people who look at this think that distributed energy resources, microgrids are sort of a component of distributed energy resources as an asset class, are going to play a huge role in the grid moving forward, right? And so ultimately you're going to have, some sort of system where there's still central, solar, wind, hydropower, nuclear, whatever we can do from a low carbon perspective. But then a lot of the load balancing is actually going to be done on the distribution grid via these distributed energy resources. It's a concept that's sometimes referred to as virtual power plants. So if you hear people talking about virtual power plants, that's what they're talking about, is essentially aggregating systems like mine together so that you can balance the grid. And that's sort of the journey that we're on the precipice of right now. And it's a pretty exciting industry to be a part of, and lots of innovation happening in the space.
The first question that kind of came into my head out of all of that. So one of it's really interesting, and I guess your background in the services, but the first time I've had this sort of conversation, and the interviewees really come from the security side of things, which is it's a really interesting angle, particularly for something as critical as energy infrastructure. So you made a very good point about how the centralized grid, the conventional way, it's got these vulnerabilities because of the nature of the design. But how about, in terms of if you have lots of distributed microgrids connected to the central grid, then you're introducing more kind of points of access into the system. So how do you manage the security of these distributed systems in a way that they don't have a negative impact on the overall system security?
Yeah, that's a fantastic question, right? And so I think the way to think about this, right, is a distributed energy system is inherently, from a structural standpoint, more resilient than a centralized system, right? It's like the first thing you learn about sort of cyber threat mitigation is you don't want single points of failure, right? It's actually one of the first things you learn in electrical engineering too, right? Is you don't want sequential circuits, you want parallel circuits, right? So it's kind of the same principle. So when you think about like the value of distributed energy resources from a threat mitigation standpoint, inherently you're starting with a stronger foundation if you have a decentralized system as opposed to a centralized system, right? So at the highest level, that's why it makes sense. With that said, right, just having a decentralized system does not inherently mean that it's safe from cyber threats, right? And so a lot of work has to go on to make sure that the people that are producing the control mechanisms that operate these types of systems, that are creating the transactive marketplaces that allow these systems to trade and all those types of things, are keeping up with the latest and greatest cybersecurity protocols. And look, I think in the United States, that's an area where we need regulators to move faster, right? I mean, ultimately, that's really the job of the government to step in and say, here are the standards that you need to design your control software to meet. And, I think they're making progress, but one could definitely argue that they're not moving fast enough on that front. And I think, again, I predominantly work in the US, so that's where I'm closest to this. But I think that's a trend that's generally happening around the world, right? Some areas of the world, like Australia, Western Australia is doing a really good job with this. The UK has been doing a pretty good job with this, or maybe a little bit ahead of other folks in terms of making sure that they're, writing the rules in a way that minimize the threat assessment. But that's definitely something we have to work on, right? Because even though it's a stronger foundation inherently when you have a decentralized system, that doesn't mean that it solves all your problems. And you still have to make sure that, every single asset that's getting access to that transactive network is doing so in a way that's as safe and secure as possible. And then you also have to make sure that you're building a system that isn't susceptible to single points of failure, right? I mean, at some point, it's inevitable that something bad is going to happen in the cyber realm at the intersection of like cyber and energy, right? Already happened many, many times. Sometimes you read articles about it, right? And so the key there is to make sure that when that inevitability occurs, the damage that any single actor can do to the system is as minimal as possible. And so that's like, generally speaking, the design philosophy when you think about mitigating cyber threats to the grid. But I think the point that we like to make a lot is that inherently starting with a decentralized infrastructure gives you a head start in making this as resilient as possible to cyber threats in the future.
And then a sort of next level down question on that, the kind of grid resiliency, you would have normally in a sort of distributed network, you would have a bit of redundancy in that network. So you could take part of the network out, but you could still, do you do a similar thing in your microgrid systems? Is there sort of a that kind of built-in redundancy or ability to deal with component elements of the system failing within the microgrid as well?
Yeah. And so, I think generally speaking, when we design these systems, there's a trade-off between economic viability and resilience that each of our customers makes, right? And, kind of how we typically work with an end-use client is we'll sit down with them, we'll learn what's important to them. And for some of our clients, we've worked with, as an example, like emergency call centers in the past, right? 911 call centers. And their general directive to us is like, we don't care how much it costs. We just need this facility to be online 100% of the time, right? Or 99.999, and then they run out of nines, right? % of the time. And you bring a design philosophy to that, right? So in that case where you sort of say, okay, the priority of the customer is resilience and they're willing to pay a premium for that, then yeah, right, you start to think about, okay, how do we split the facility so any single equipment failure isn't going to impact the whole facility, bringing multiple feeders into buildings, using redundant resources, having multiple inverters and things like that to feed, different components of the system. More commonly, right, people are concerned about the economics, right? And resilience costs money. And so, I think inherently a lot of times the systems we're building today from a microgrid perspective sit behind the meter, and they're more redundant and more resilient than not having a microgrid would be, meaning that when the grid fails, our microgrid will turn on. But if the grid fails and our microgrid breaks, then they're not going to have power, right? And so, again, I think that's where most of our customers sit, which is they look at it like a hedge, which is, if the grid goes out, I have a system that can power my facility. If both of those things fail, then I'm just having a really bad day and I'm going to send everyone home, right? But, for mission critical facilities that, don't have that option or have to be online no matter what, there's definitely, sort of a design philosophy we bring to that. And it really comes down to sort of economic trade-off. Does that make sense?
Yeah, sure. You've mentioned one type of application where you're working, but I think that's something, it would be interesting to know a bit more about the sorts of places that you are building these things.
Yeah. So our business is really focused on commercial and industrial applications, right? And so there's a bunch of different segments where microgrids are taking off as an asset class. The biggest one is probably in national security, right? So like the U.S. Department of Defense is basically building microgrids for every U.S. military base in the world. I think most sort of NATO type countries are doing the same stuff, right? So that's probably the biggest segment. We don't work in that segment, but it's huge. We focus on C&I applications. And so where we're doing a lot of work right now, I think there's sort of a broad swath, but we're doing a lot of work in heavy industry. So like manufacturing facilities, things like that. Data centers are a big market for us right now. Healthcare, agriculture, increasingly warehouses. So this has really been sort of a post-COVID thing where, the e-commerce revolution has kind of been accelerated, I think, a lot faster than people thought it was going to go. And so now, if you order something online and you expect it to be there on a Tuesday and it doesn't show up on a Tuesday, it's a big problem. And so increasingly, warehouse and logistics companies are looking to systems like this to make sure that if there's an outage, they can still service their customers. And then, one of the things I'm most excited about is we're doing a lot of work at the intersection of electricity and e-mobility right now, right? Or electricity and transportation. And so, especially for fleet vehicles, right? When you think about, sort of a facility that might have, 20, 30, 50 electric vehicles that need to charge there, there's a really, really compelling case for using microgrids to, in concert charge those vehicles. And so that's probably the fastest growing segment of our business right now and something we're really excited about. So, I think in summation, the applicability of these types of systems is really widespread. And there's a lot of different industries that are excited about this right now. And a lot of industries that we're excited about working with.
Cool. I mean, the EV one is an interesting, obviously to me and the listeners, is the kind of thing you're doing there? Because one of the problems now, EVs are becoming more popular. Actually, I just saw someone posting about this today where some high power chargers have been installed somewhere, and actually they had a grid problem, so the chargers were inoperable. But it wasn't like a temporary grid problem. Somehow they'd managed to install these chargers somewhere where the grid didn't have the capacity. So they were like, they will never work. Well, certainly not for a long time. And I know getting larger grid connections in a lot of countries is really difficult, expensive, time consuming. And when you're charging like one vehicle at home, it's not a problem. But like you said, 20 or even, how do you do 200 trucks running out of a depot? Where you need megawatts of power. These are the actual. You kind of almost go beyond the microgrid concept there, in that it's just not possible to upgrade the existing grid in a way that can support those things. So, do you think is that where you see microgrid systems coming in that kind of situation?
Yeah, absolutely. I mean, look, I think it's one of the most fascinating problems that exists in climate right now, right? So if you think about this at the highest level, if you talk to the UN, right, their solution to the climate crisis is electrify everything, right? That's basically what you can boil it down to. They want to take all sources of emissions and turn them into electricity, which makes sense. But one of the big problems with doing that is we did not build an electric grid that is capable of doing that, right? And so, I'm sitting in California right now. To give you an example, right now in California, roughly 50% of greenhouse gas emissions come from transportation, right? The goal is to not sell an internal combustion vehicle after 2035, which is 12 years from now. The electric grid in California is not capable today of servicing all those electric vehicles, right? And so, a lot of people think about this in terms of like it's a generation problem. It's not. We can generate enough kilowatt hours to charge all those vehicles. But what's finite is the transportation network that those electrons travel on, right? And so transmission and distribution ends up being the biggest barrier, in my view, to wide-scale adoption of EVs. That's especially problematic in the fleet sector. So in the U.S., as an example, fleet vehicles are 6% of vehicles on the road, but 25% of vehicle miles driven. And so essentially, when you have residential electric vehicles that are sort of distributed across a neighborhood, there's a lot of stuff you can do from a software perspective and also from like a regulatory and a tariff perspective to incentivize people to charge at different times of day and sort of get there, right, in terms of using the existing grid to charge all those vehicles. Whether or not that's possible to do with like 100% electric vehicles remains an outstanding question that people debate all the time. But you can get a lot closer to 100% in the passenger vehicle side of things than you can on fleets. When it comes to fleets, it's basically impossible, right? So to give you an example, we're working with a customer right now who has sort of a warehouse and then 30 trucks that they use to distribute food in an area. Their building right now has a peak load of about a megawatt. When they looked at charging those 30 vehicles, their peak load was about 10 megawatts. Then they brought in like software experts and they put in this really sophisticated charging management system, and we got them down to about 3.5 megawatts of peak demand. But that's still 3.5xing their current load requirement. And when they go to the utility and they say, hey, we have a megawatt service now, we need a 4.5 megawatt service in order to electrify our fleet, the utility just isn't capable of providing that amount of power. And so ultimately, the way you do that is you start with a giant battery, right? And this is sort of the intersection of stationary storage and electrification of transportation, which is a big way you solve this problem is you use a big stationary battery to sort of manage demand at the facility level. And when you put in that giant battery, you can solve maybe like 75% of the problem, right? And then, when you start thinking about, okay, what's the most economically viable way to charge this battery, it tends to make sense, depending on region of the world you're in, to add a bunch of solar to the maximum extent that's possible as well. And then if you have specific resilience concerns, maybe you want to add, dispatchable generators as well on top of that, right? And so that's essentially what starts the thought process in the fleet sector about using microgrids is we can't get power from the utility. Therefore, we have to make the power ourselves. How do we do that? And, sort of once you run down that road, a lot of times the answer you come to is we should build a microgrid.
Yeah. Yeah. And it's an interesting, you mentioned you're in California and
yeah.
One of the other sort of things that's been in the news a little bit recently, and maybe more last year, although I was maybe because I was in America last year and I haven't been recently this year, but there's a lot of talk about the problems in California with the grid caused by sort of unbalanced power and basically too much solar at certain times, et cetera, causing the grid to have problems. And I'd heard that before. Actually, I think this is an issue that's been going on for some time because it's always sunny in California. So, you've got lots of opportunity for solar. People have solar. But in the past, they were quite good incentives to generate with solar. But effectively, it was putting too much power on the grid and then causing all sorts of other issues. Is that still a thing?
Yeah. I mean, one of the reasons I'm sitting in California right now is California has probably the worst grid in the developed world in terms of the threat assessment, right? And so, yeah, right, there's a ton of capacity problems. And I think largely, right, these are problems that are solvable, but take time to solve. And so one of the reasons California is in the situation that they're in is they were ahead of the game in terms of trying to convert to, renewable energy as quickly as possible. And I think, in a lot of ways, the people that made those decisions should be lauded for doing it. Yeah. Because a lot of the reasons that we have solar elsewhere in the world is because of some of the innovation that happened in California in the early days. Yeah. Right. And that's true of Europe as well. Right. Mm-hmm. I think a lot of, European countries single out Germany. Right. Being early in this, they've definitely paid a price for doing that. But without them doing that in the first place, we probably wouldn't be where we are in terms of, the evolution of clean energy as an asset class right now. But because of a lot of mistakes that were made, 10, 15 years ago, when California was first starting to put renewable energy resources on the grid, there are all sorts of load balancing problems right now. And then those are exacerbated by climate problems, right? So the capacity issues on the California grid are concerning but fixable. Mm-hmm. The thing that's not fixable is they keep starting fires, right? And so the biggest problem facing the California grid today is if you think about a map of California, basically all the electricity is generated on the east side of the state and all the electricity is consumed on the west side of the state, on the coast. Yeah. And there's wires that bring that electricity across the state. And in the middle is 100 million dead trees because California has been in a drought, 1,000-year drought for the last 10, 15 years. It's been the worst drought that California's experienced in a long, long, long time. Yeah. And so every time a line falls, you run the risk of starting a catastrophic wildfire, which has happened a lot in recent years. And so the utilities, in order to make sure that they're not starting fires, when sort of wind and humidity conditions dictate, have to turn the electric grid off. That's really the only thing that you can do.
Oh, wow.
And that's probably the biggest systemic problem facing California right now. And that's really the thing that's getting people to adopt distributed energy resources at an unprecedented pace. But there's a lot of those types of systemic issues that are happening in California right now. And our view is that, this is just like the first of many places this is going to happen, right? Again, if you get back to that original thesis, like the grid really wasn't built for the future. It was built for the past. And if we're going to successfully innovate and sort of execute the energy transition, we have to fundamentally rethink how we're utilizing the electric grid, and that's sort of a huge part of how we do it. And California is kind of on the front lines of doing that right now.
Yeah, I mean, that when you think about it, it's quite an extraordinary set of problems. I live in the UK, so it rains all the time, so we don't quite have the same problems. But even without the sort of extreme drought, I mean, we have the odd bit of drought and stuff, and we started. I don't ever remember seeing wildfires in the UK as a child, but the last few years we have had some, albeit a tiny compared to the scale of the stuff you're getting in the US. But with all that said, I like in the last 2 or 3 months, have the number of people who I know have had like massive issues with availability of electrical power when they're planning new industrial sites in the UK. It just seems to be the thing now. Can I get power? And this isn't even for people thinking about like a huge fleet of EV trucks or something. This is just to build a normal factory.
Yeah.
The issue is the power, and there's a grid problem. And the answer from the grid company is we can fix it, but it'll take 3 years. And this is one of the problems with the centralized grid. By its nature, it's expensive because everything's sort of very special, but it takes a long time to make any changes at all. And it just doesn't always seem or ever seem to keep up with the obviously the changing needs of users and consumers. And that, let's say, that's without even really factoring in any sort of electrification extra demand. So, it's a huge challenge.
No, I think that's 100% right. And, look, I think, getting back to sort of the broader thesis about, why the decentralization of the energy system, in my opinion, is kind of inevitable, right? Look, in a lot of ways, I think the UK will be on the front line of the climate crisis in other ways, right? Maybe it's not wildfires, maybe it's, increased storms, right? That kind of stuff. But like, here's another thing, right? I mean, the biggest energy shock in the UK over the past 2 years has been Russia invading Ukraine, right? And so, when you start to think about sort of the interconnected nature of our legacy energy system, right? The reality of the situation is that the people who control most of the commodity of fossil fuels, right, who sort of dictate the prices and the availability of that on a global scale, a lot of those people are not people that we have shared values.
That's a nice way of putting it.
It's just the reality of the situation, right?
AKA, they're not very nice people.
Yeah, I mean, look, like the reality of the situation is that like a big reason that Vladimir Putin did what he did is because he, whether this was right or wrong, believed that Europe wasn't going to do shit about it because he controlled the natural gas pipe.
Yeah.
Right. And so as we start to think about these things that happened over and over and over again, I think a lot of countries are thinking about this in terms of, look, like we have to stop being reliant on these types of systems where people can just do whatever they want to us because we need their energy, right? Yeah. And so what are you seeing in Europe right now, right? You're seeing people try to convert to heat pumps as quickly as humanly possible, right? Yep. You're trying to see people, build renewable energy assets as quickly as humanly possible. Yep. And so like there's a lot of different reasons that, taking control of energy inputs matters for countries, matters for companies, matters for individual people. And But, I think ultimately, right, the idea is that if you're reliant on this like global system that's interconnected where bad people can have outsized influences on what you pay to, drive to work or heat your home, that's not a good situation to be in. And we should try to evolve past
150% agree if it's possible, to the point, I think in some ways, it is terrible, like what's happened in Europe. And you can't even put it in words, but the price of energy has just gone completely haywire, and it has exposed this huge issue with the way, it's the way the system works, but not necessarily in a kind of from a technical sense, in a commercial sense, because of all these effectively the pricing mechanisms that they have for the electricity generation. So even though in the region I live in, almost none of our electricity comes from gas, we still pay the price as if it was coming from gas because of how the centralized system works. So there's kind of, that's been opened up, and like everyone's going, well, hang on, if we're getting all our energy from renewables and wind power and nuclear, why are we paying it based on gas? So that's happened. But then the costs have just gone crazy, and if you can, it makes that investment so much more practical. And personally, in the last year or so, I've invested in solar and renewable, and battery storage. Actually, the battery storage really was the no-brainer for my domestic situation. The solar
100%.
Solar is a bit of a longer payback, but the before I didn't use enough electricity, or the costs weren't high enough, and the systems were a bit more expensive. So the thing is evolving, and it's driving this innovation in the system. But it's really interesting that you're working, obviously not at, you're at the commercial level. So big factories, big consumers are potentially that. Do you think that's going to make a difference to the, we've got the grid stability, the grid problems? Like actually, if a few of these big users pull off and start to charge batteries at night and have their solar and, manage that whole thing, do you think that will have a positive kind of ripple out impact on the grid?
I think it can have a positive ripple out impact on the grid, right? Look, I think if you think about this at the highest level, right? 25 years ago, if you actually sat and looked at where you were getting your energy from and what market forces that exposed you to, you would come to the conclusion that sucked, but like, there's nothing you could really do about it, right? Like there wasn't an alternative that was better than the way the legacy energy system worked. If you do that same thought experiment today, right, there are alternatives that are a lot better, right? And so like, again, in 1999, if you were saying, look, my commodity electricity price or my commodity gas price just went up 5x in the last month because some dictator in Russia invaded a country for no reason, right? Like, what are you going to do? There's nothing you can do. If you have that situation today, right, you go out, you buy solar panels, you put them on your roof, you put a battery in your garage, right? Then you're 50% there, right? And so like, that's the big thing that's changed is that like the problem has always been the problem, right? The energy system has always been non-ideal, non-utilitarian, right? Today we can do something about it, right? Now, to your second question, I think we can do that. That makes the grid better for everyone, but it's not a guarantee, right? And so to give you an example, right, like one of the things that I worry a lot about is that the proliferation of distributed energy is actually going to make energy justice or environmental justice a bigger problem, not a smaller problem, right? So if you think about like who we build systems for, right? Typically they're C&I customers with good credit, right? And so if you're a C&I customer with good credit, we'll come in, we'll build you a system, we'll finance it, you'll save money, you'll come off the grid, right? But the costs of managing the grid are still fixed. So now they just get allocated to a smaller percentage of people. And the people who are still on the grid tend to be disproportionately, middle and lower income people, smaller businesses, public, properties, things like that. And so if we do this poorly, right, if we execute this energy transition poorly, we could definitely be in a situation where we make the problem worse, not better, right? Especially from like an EJ perspective. But that's why we have to be thoughtful about it, right? And I think if we really focus on how we can build this, energy system of the 21st century, in a way that's, sustainable, reliable, affordable, and, just, it's totally possible to do, right? It just requires like a bunch of people coming together and figuring out how to do it. And I don't know, we've done things that are hard before. There's a question, at least in my country, about are we still capable of doing hard things? And I don't know I don't know what the answer to that question is.
Yeah.
But like we've done things that are harder than this before. And, again, the technology exists, the market structures generally exist. It's just a matter of like sort of everyone getting on the same page. And unfortunately, we're still in sort of from like a regulatory and policy standpoint, we're still in an ecosystem where the leaders of my country spend more time fighting about whether climate change is real or not than they do actually trying to figure out like what's the best way to build this system. But that's changing, right? Like maybe, hopefully, I don't think it's changing fast enough, but that's changing. And I think you're getting more and more folks who are coming to the table, trying to think about, how do we build this in a way where, we're maximizing the benefits for everyone involved. And I don't know, there's reason for optimism, right?
It's good. I mean, you made a really good point there, and it's sort of opposite to what I had in my head, because I was thinking, if I was a government or a grid operator and I had these issues, what I would do, I'd go to my 10 biggest consumers and basically say, right, get yourselves off my grid. You have your own, put your microgrid in, and probably work with them to try and, Pareto, we take the biggest consumers off. Yeah. Right, that fixes my problem. But actually, my biggest consumer is also paying for the system. So yeah, I hadn't even thought about that. And then so if all these big consumers go off the grid, we still have a pretty fixed operating cost of a distribution system. I mean, we need to get rid of all these horrible backup gas, peaker plants. Yeah. But we're still stuck with them for a good few years. So that whole thing, that's a massive problem, isn't it?
Yeah, no, for sure, right? And it's the reason that energy has always been a public-private partnership, right? I mean, these types of trade-offs that you're talking about or we're talking about right now, they're not new, right? It's the reason that, every major energy system in the world is a public-private partnership, right? Where the government is heavily involved. So look, there are a lot of people in my industry who will tell you that like energy is a free market, and they're lying to you. No, it is not, right? Nothing about energy, whether it's from, oil and gas or it's power or it's whatever you're talking about, nothing is a free market. It's the most heavily regulated industry, maybe outside of healthcare, right? It's the most heavily regulated industry in the world today. And it should be, right? Because the energy system has an impact on all of us and the externalities are massive. And so we need to think about making decisions about the energy system as a collective, not as individuals, right? That's just like kind of the way it works. And so look, I think what you're seeing in the market today is, quite frankly, like in most countries, the public sector isn't doing its job.
Yeah.
Right. You have like a ton of private sector innovation. The climate tech, sort of ecosystem is growing really quickly. I think what you're starting to see is, demand outside of government requirements, right? Like the ESG movement with Fortune 500 companies and, all these different folks are demanding these types of solutions. And the, public sector just isn't working fast enough to sort of deliver on that. Look, in the US, right, we've definitely seen a huge sea change over the past 2 years where I think, the Biden administration has come in and I think done a lot of incredibly innovative things to try to sort of jumpstart the transition. I think you're seeing things, right, in the EU and Australia, China, right, that are very, sort of optimistic and could lead you to the conclusion that like governments are really going to play the role. So, again, look, historically, the public sector has failed us when it comes to the energy transition. I think it's getting better. And again, the question is it getting better fast enough? And, that's kind of the unanswerable question right now.
Yeah. Yeah. So, conscious of the time, but I don't know if this is a good question or not. I have the feeling it might be one of those questions that's quite hard to answer. But so your systems you're heavily dependent on some key hardware systems, so batteries, solar, power electronics, because you know all the different inverters and power converters that go into those systems, and then you've got your kind of management software, things like that. What do you see kind of happening with those systems? You know, in the next couple of years, innovations coming through. Is there stuff happening that's kind of making these things better, cheaper, easier to work with, or what's the state of play on the hardware side?
No, it's a good question. Look, I think so. Look, on the optimistic front, right? Like the area where there's the most innovation right now is around batteries, right? And so we are literally just scratching the surface of what is possible to do with battery energy storage systems, right? And really, on a mainstream sort of way, we're only using one chemistry, which is lithium ion, right? There's different versions of that, but it's all basically lithium ion. And so the most innovative sector right now is, batteries. We're looking at all sorts of different chemistries, right? Some we're really excited about. Some might not work, right? But that's going to be where you're going to see the most innovation over time, over the next 5-10 years. And ultimately, right, what lithium ion batteries are really, really good at doing is sort of daily storage, right? But if you really want to run the grid on high penetrations of renewable energy, there's seasonal storage and long duration storage challenges that haven't been solved, and lithium ion is probably not the right technology to solve. And so, there are things that we look at that we're pretty optimistic about, but it's still kind of too early to tell in terms of, how quickly that's going to happen. I tend to be optimistic, right? So from an innovation standpoint, I think that's where you're going to see the most movement over the next, 5-10 years, right? Is battery chemistry, and what we're able to do. And that'll sort of be like the hub of the wheel, right? There's a ton of innovation happening in all the sectors you mentioned. But I think where you'll see the most movement is on the battery chemistry side of things. But the big challenge over the next 10 years is going to be manufacturing all this stuff, right? So right now, basically what you've seen from, if you sort of group all these technologies together and you call them, I don't know, clean tech, right?
Yeah.
What you've seen is skyrocketing demand and, I don't know, supply that's very much struggling to keep up with that demand, right? So case in point, right, is everyone in Europe right now, or most people in Europe right now, want a heat pump. Problem, can't get heat pumps, right? Because we can't manufacture heat pumps fast enough.
Same with solar.
Yeah, it's happening with solar. It's a huge problem. It's a huge problem in batteries right now. It's even a problem with the biggest problem right now globally is with switchgear and controls, right? Where the actual power electronics that's required to install this stuff and put them in buildings has been absolutely crushed with demand, and the supply chain is all sorts of messed up, right? And so, again, what we have to do over the next 10 years, and I think really the biggest barrier to success is, can we ramp up manufacturing capacity quickly enough to meet demand? And the early results are no, right? Now some of this has been because of COVID and the pandemic and some of the geopolitical stuff that's going on, right?
Well, that's a big issue, isn't it? Because actually one of the big problems that is in this supply chain, and we've talked about security and system security. China kind of has done a lot of the key hardware elements, power converters, solar panels, even batteries. Actually, they've done really well at certainly compared to the UK. A lot of the hardware is coming in from China. So then you're building these super resilient, high security systems with Chinese hardware. Is that kind of?
No, yeah, it's a very real thing, right? So just so people understand this, because I think it's a very key point. If you look at a lot of these technologies, I'll single out solar and storage, and you look at the global market, in a lot of these areas, China has more than 90% market share. not like 50% market share, like 90, 95% market share with respect to a lot of these technologies.
There are whole cities in China where all they do, there are just company after company where they make solar panels. It's like a solar city is all they do, and the government invested in it years ago. They threw up factories, they put billions in, and now we're kind of going, oh God,
Yeah. So no, I mean that's the thing, right? So I mean I think again, when we talk about this being like a public-private partnership, right? Yes, does the fact that a lot of the equipment that we buy comes from China concern me? Yeah. Now look, there are things we do, right? I mean, I think like one of the biggest initiatives in our company over the past like year and a half has been making sure that we understand the supply chain and where the raw materials are coming from, and making sure that where we're getting our products from are consistent with our company's value from like a human rights perspective, right? There are things we can do, but at the end of the day, like, is Scale Microgrids gonna influence like the China-US geopolitical situation? We are not, right? And so we're gonna be price takers, right? Like, people need to work this stuff out. And so, I think ultimately, right, we're in a situation right now where if you want to build a renewable energy infrastructure to serve the world, China is the most important manufacturing partner you can have. And ultimately, you have kind of two choices, right? You can figure out how to make that work, or you can build manufacturing capacity in your own country. And I think the right answer is probably a mix of both. But again, right, it's one of the things that I've talked to a lot of different elected officials about, which is, building manufacturing capacity takes time. So we're now starting to build, solar plants and battery plants in the US. If you want to, meet the goals that we've set for 2030, right, and it takes you 5 years to build that manufacturing capacity,
it's too late.
It's going to be really hard to deploy that by 2030. And so a lot of these problems are like really, really complicated. And we got to figure out how to navigate, right? But it's possible to do, and I think that's kind of what the optimistic people in our space that I try to surround myself with try to focus on, right? Is all these problems are solvable. We just got to do a better job solving them, and I think we can do that.
Brilliant. Well, I think, and on that, because we've run over time, I think that's a good point to bring it to a close. I don't know if you've got any sort of final thoughts in terms of what your big projects coming up for you, or things that you're excited about in the next year.
Yeah, so maybe you can have me back to talk about that, because there's a lot of stuff I'm excited about. I mean, the big project, the big stuff I'm excited about is really on the virtual power plant landscape, right? So really, what I'm focusing most of my time on right now is the aggregation of these types of systems, right? So how do you take 50 microgrids that are in California and build sort of a system that allows those to operate as a group or as a portfolio in an optimal way? And so that from like sort of a business model technology standpoint is something I'm really excited about. But no, man, thank you so much for having me today. This was awesome. I really enjoyed the conversation. And if people want to find me, scalemicrogrids.com is our website, and you can reach out and people will put you in touch with me, and I'm happy to answer any questions I can.
Great. Thanks, Tim. So for listeners, I'll put some notes in and put some links to Tim, so you can find him and the company and stuff like that. So that'll all be in the show notes, which are down below. And that's all we've got time for today. But thank you very much, Tim. And I think we will have you back, because it's just, I mean, it's flown by, but that was really great. Thank you.
Anytime, man. Thanks so much for having me.